Hi, my name is Kishan Agarwal. I am from CSE Section B. Today I am presenting my tech talk of chemistry, and my topic is possible power generation with nature's high efficiency technology. So let's begin. Power generation. So electricity is not freely available in nature, so it must be produced. That is, we have to transform other forms of energy into electricity. So production is carried out in power stations, also called power plants. Electricity is most often generated at a power plant by electromechanical generators, primarily driven by heat engines fueled by combustion or nuclear fission, but also by other means such as kinetic energy of flowing wind and water. Other energy sources include solar, photovoltaics, and geothermal power. So, phasing out coal-fired power station, eventually gas-fired power station capturing the greenhouse gas emissions is an important part of the energy transformation required to limit climate change. Vastly more solar power and wind power is forecast to be required, with electricity demand increasing strongly with further electrification of transport, homes and industry. So just look at just we see the history of electricity, that is power generation. So the fundamental principles of electricity generation were discovered in the 1820s and early 1830s by British scientist Michael Faraday. His method, still used today, is for electricity to be generated by the movement of a loop of wire, a Faraday disc, between the poles of a magnet. Central power station became economically practical with the development of alternating current, that is AC power transmission, using power transformers to transmit power at high voltage and with low loss. Commercially, electricity production started with the coupling of the dynamo to the hydraulic turbines. The mechanical production of electric power began the second industrial revolution and made possible several inventions using electricity, with the major contributors being Thomas Alva Edison and Nikola Tesla. Previously, the only way to produce electricity was by chemical reactions or using battery cells, and the only practical use of electricity was for telegraph. But now we can see electricity used for many purposes. Electricity generation at central power stations started in 1882 when a steam engine driving a dynamo at Pearl Street Station produced a DC current that powered public lighting on Pearl Street, New York. The new technology was quickly adopted by many cities around the world, which adapted the gas-fueled street lights to electric power. Soon after, electric lights would be used in public buildings, in businesses, and to power public transport such as trains. The first power plant used water power or coal. Today, a variety of energy sources are used such as coal, nuclear, natural gas, hydroelectricity, wind and oil, as well as solar energy, tidal power and geothermal sources. So let's quickly see what are the types of energy sources. As usual, we know that there are two kinds of energy sources: non-renewable energy sources and renewable energy resources. So there are two major categories of energy. They are renewable and non-renewable. So let's see what is non-renewable energy. Non-renewable energy resources are available in the limited supplies, usually because they take a long time to replenish. The advantage of these non-renewable resources is that power plants that we use them are able to produce more power on demand. The non-renewable resources are coal, nuclear, oil, natural gas. Renewable energy. Renewable resources, on the other hand, replenish themselves. The five major renewable resources are solar, wind, water, also called as hydro, biomass or organic materials from plants and animals, geothermal, which is naturally occurring heat from the earth. So, non-renewable energy and climate change. When coal, natural gas and oil are burned to produce energy, they emit heat trapping gases such as carbon dioxide. This process of trapping heat what drives climate change, and failure to address these problems is what's catalyzing the current climate crisis. Fossil fuels are hydrocarbons containing materials like coal or gas that are found in the Earth's crust and formed in the geological past from the remains of living organisms. These energy sources account for the majority of world's greenhouse gas emissions. So these are the top 10 energy resources of renewable and non-renewable resources. Renewable resources such as biomass, geothermal, hydropower, solar and wind, whereas non-renewable coal, natural gas, petroleum, propane, uranium. So just we see why we need power generation through nature's, what we can say. So why we are moving towards renewable resources, why not through non-renewable resources? So the rapidly growing fuel consumption in engines and turbines that power the world's transportation vehicles and power generation plants will nearly exhaust the world's supply of petroleum by the end of the next century. These engines and turbines run at high heat input temperatures because their efficiency is limited by the Carnot cycle. Muscles used for propulsion by animals are not limited in efficiency by the Carnot cycle. So we see dolphins getting 3000 miles of travel from a food quantity that contains the energy equivalent of 1 gallon of gasoline. Leaves on plants capture the energy in sunlight to extract carbon from the carbon dioxide in the air and hydrogen from water to manufacture carbohydrates. Scientists and engineers studying these processes are amazed by the computing power and data storage required to make these processes work. For example, a tiny grape seed contains the data and structural technology required for quickly constructing the plant's fuel producing leaves and the structure that supports them. Even the stiff thorn that discourages intruders from entering the grape bush has an effective design. The data stored in the seed specifies the color of the grape plant's blossoms, commands the production of the sugar-containing fluid that goes into the grapes, and even the data content of the next generation seeds in the globules of each grape berry. In this report, we explore energy conversion process that nature has developed in the plants and animals. We explore the possibilities of adapting them into the techniques that reduce consumption of petroleum fuels. Let's begin. Renewable electricity generation technology. A renewable electricity generation technology harnesses a naturally existing energy flux such as wind, sun, heat or tides and converts that flux to electricity. Natural phenomena have varying time constants, cycles and energy densities. To tap these sources of energy, renewable electricity generation technology must be located where the natural energy flux occurs. Unlike conventional fossil fuels and nuclear electricity generating facilities, which can be located at some distance from their fuel sources, renewable technology also follows a paradigm somewhat different from conventional energy source, in that renewable energy can be thought of manufactured energy with the largest proportion of cost, external energy and material inputs occurring during the manufacturing process, although conventional processes such as nuclear and coal-powered electricity generation have a high proportion of capital to fuel costs. All renewable technologies except for biomass generated electricity, that is biopower, have no fuel cost. The trade-off is the ongoing and future cost of fossil fuel against the present fixed capital cost of renewable energy technologies. Nature's high efficiency technology. So let's see wind power generation. Wind power generation means getting the electrical energy by converting wind energy into rotating energy of the blades and converting that rotating energy into electrical energy by the generator. Wind energy increases with the cube of wind speed. Therefore, WTGs should be installed in the higher wind spread area. So, introduction of wind power generation has been increasing the world has the following characteristics. No carbon dioxide emission. Wind is a safe energy source existing everywhere, and there is no need to worry about depletion like fossil fuel. Simple equipment and easy operation. Few affection to the nature environment. In the world today, progress of technology to develop larger WTGs are remarkable, and it makes electric output per 1 WTG unit increased, and large field of WTGs called wind farm has developed. Technologies of building offshore WTGs are progressing as well. So by implementing wind energy, we can reduce the usage of fossil fuel so that it can reduce the emission of carbon dioxide and other greenhouses in our environment. So these are the parts which are used in wind energy generation. This is the generator which converts wind energy into electrical energy. This is turbine, and this is the rotating part of wind. This is the ratio, how the output of the electricity depends on the speed of wind. Now next move to solar power generation. Energy can be harnessed directly from the sun, even in cloudy weather. Solar energy is used worldwide and is increasingly popular for generating electricity or heating and desalinization of water. Solar power is generated in two main ways. So solar energy is generated in mainly two ways, that is photovoltaics and concentrated solar power. So first of all, photovoltaics, also called solar cells, are electronic device that converts sunlight directly into electricity. The modern solar cell is likely an image most people would recognize. They are the panels installed on houses and in calculators. They were invented in 1954 at Bell Telephone Laboratories in the United States. Today, PV is one of the fastest growing renewable energy technologies and is ready to play a major role in future global electricity generation. Solar PV installations can be combined to provide electricity a commercial scale or arranged in a smaller configurations for mini grids or personal use. Using solar PV to power mini grid is an excellent way to bring electricity access to people who not live near the power transmission lines, particularly in developing countries with excellent solar energy resources. The cost of manufacturing solar panels has plummeted dramatically in the last decades, making them not only affordable but often the cheapest form of electricity. Solar panels have a lifespan of roughly 30 years and come in variety of shapes depending on the type of material used in the manufacturing. Concentrated solar power. Concentrated solar power, that is CSP, uses mirror to concentrate solar rays. These rays heat fluid which creates steam to drive a turbine and generate electricity. CSP is used to generate electricity in large-scale power plants. A CSP power plant usually features a field of mirrors that redirect rays to a tall, thin tower. One of the main advantages of a CSP power plant over a solar PV power plant is that it can be equipped with molten salts in which heat can be stored, allowing electricity to be generated after the sun has set. So next is hydropower generation, the electricity using water. So hydroelectric power, also called as hydropower, electricity produced from generators driven by turbines that converts the potential energy of falling or fast flowing water into mechanical energy. In the early 21st century, hydroelectric power was the most widely utilized form of renewable energy. In 2019, it accounted for more than 18% of the world's total power generation capacity. In the generation of hydroelectric power, water is collected or stored at a higher elevation and led downward through large pipes or tunnels to a lower elevation. The difference in these two elevations is known as the head. At the end of its passage down the pipes, the falling water causes turbines to rotate. The turbine in turn drives generator, which converts the turbine's mechanical energy into electricity. Transformers are then used to convert the alternating voltage suitable for generators to a higher voltage suitable for long distance transmission. The structure that houses the turbines and generators and into which the pipes or penstocks feed is called powerhouse. So hydroelectric power plants are usually located in dams that impound rivers, thereby raising the level of the water behind the dam, creating a high head as is feasible. The potential power that can be derived from a volume of water is directly proportional to the working head, so that a high head installation requires a smaller volume of water than a low head installation to produce an equal amount of power. In some dams, the powerhouse is constructed on one flank of the dam, part of the dam being used as spillway over which excess water is discharged in times of flood. Where the rivers flow in a narrow steep gorge, the powerhouse may be located within the dam itself. As we can see in the below picture, how the reservoir pumps the water and the flowing water rotates the turbine, and that turbine are connected to a generator which converts this mechanical energy into electrical energy, and that is then connected to the power station. Falling water is one of the three principal sources of energy used to generate electric power. The other two being fossil fuels and nuclear fuels. Hydroelectricity power has certain advantages over these other resources. It is commonly renewable owing to recurring nature of the hydrological cycle. It does not produce thermal pollution. However, some dams can produce methane from the decomposition of vegetation underwater. Hydroelectric power is preferred energy source in areas with heavy rainfall and with hilly or mountain regions that are in reasonably close proximity to the main load centers. Some large hydro sites that are remote from load centers may be sufficiently attractive to justify the long high voltage transmission lines. Small local hydro sites may be economically, particularly if they combine storage of water during light loads with electricity production during peak. Many of the negative environmental impacts of the hydroelectric power come from the associated dams, which can be interrupt the migrants of swamping fishes such as salmon and permanently submerge or displace ecological and human communities as the reservoir fills. So that was about hydro power plant. So this is the picture showing inside a hydro power plant, how the intake of water takes place, and the control gate, penstock, turbine, and then the turbine is connected to a generator, transformer, and that transformer is connected to the powerhouse and then power lines, and the outflow is also after the turbine. So there are many ways from which we can reduce the usage of fossil fuels, that is non-renewable resources. Some of them we have discussed like solar, wind and hydro, and there are many other like biogas, etc. So we can reduce the pollution or we can reduce the greenhouse gases so that the temperature will be maintained. Thank you.